Simon is one of the top contributors to Scala compiler. You will definitely see his name if you go on the Jitter channel or just look through the pull requests. And recently he's also been encouraging documentation to improve for people to contribute to Scala compiler itself. So definitely check out some of the documentation projects he's been doing there. So I'll hand over to you, Simon.
Okay. So. Okay, so nice to see all of you. I'm doing the talk about implementation challenges of language simplification, and when I proposed this talk, I assumed that the whole conference would consist of like 20 people, all of them giving talks, all of them knowing compiler internals, but this turned out to be wrong, which I learned 2 days ago. So if there's anything which is not detailed enough or is confusing, just shout explain or shout anything, then I try to explain as much as possible. So wait, language changes, aren't we at developer tool conference? Aren't like language changes the one thing we don't actually want because it's like more work for everyone? So yeah. I just say like ScalaSphere is the ultimate development tool, so that's why I'm speaking at the DevTools Summit after Howie Lee voiced that concern so nicely at John Britty's talk earlier today. So everybody might have a thought once or twice or maybe a dozen times in his work on Scala. Wouldn't the language be better just without this small, simple feature over there? And can't we just remove it? Can't we just deprecate it? And well, probably not. So follow me down the rabbit hole in which I show you a few simplification ideas. They are not like the most important things or the most useful things, or you don't even have to agree that these changes should be done, but I just picked a few ideas and I try to show you how even small changes to the language can have large and unexpected effects. So the first change I want to show you is to remove a default import. The second change is to reduce the amount of implicit widening conversions going on in the compiler, and the third one is right biasing either. So as some of you might be aware, every compilation unit of Scala source code, which basically means every Scala source code file has some hidden imports added by the compiler. So at the top of each file, imagine as if java.lang.star was imported, scala._ was imported, and scala.predef was imported. So there's a lot of stuff in there, and while the second and the third import statement, we did a lot of work fixing bugs, removing pointless things from default imports. Java.lang is basically everything in the last 20 years which was never removed or changed in any kind of shape. And yeah, so what's so bad about a java.lang.star? There's like, you can categorize those things in many categories. I just picked a few of them. It's like there are some things in there which are just plain useless, like java.lang.void or java.lang.compiler, which was like a just-in-time compilation class added in Java 1.0 with the remark, well, we implement that later. And in Java 1.1, they declared, well, later is never, we aren't gonna bother with implementing this class, so it's there, it doesn't do anything, and it kind of sucks. So the next part is basically java.lang.double, class, string, reflect. These are all types or names which are hidden by later imports. So we import them, but they can never actually used because Scala._, also imports things with these names, so they never actually show up. And the important thing is actually last line, Scala.lang, java.lang.reflect, because these imports don't work only on classes, interfaces, exceptions, abstract classes and stuff. They also work on packages. So every package in java.lang.star is actually imported. And some of them are hidden again, like reflect by Scala.reflect, but others are just there and we have to deal with them. And some classes in there are just plain dangerous, like thread or system, which like people should just don't touch them if they don't know exactly what they're going to do. So it would be a reasonable idea to just get rid of java.lang.import of the java.lang import, because we as Scala developers have no control over fixes or changes. Most classes are actually not that useful, and those default imports just look awkward on other platforms like Scala.js. Why is there a default java.lang import on Scala.js? And additionally, dependencies are less obvious. So a really naive way to figure out how many dependencies on Java stuff I have is just to grep for import java.lang. Well, that doesn't work because import is nowhere in the source file. So this is basically what we want to do. The bad thing is this is absolutely not source compatible, and a lot of code will break. So the idea is to replace the star import, which imports everything, by something more specific, and I'm intentionally vague about what these specific means are. We see why this is important later. The idea is that in the next stage, after we have basically enumerated everything which is in java.lang, we pick the few things we actually want to keep, like java.lang.string or java.lang.class and stuff like this, and we deprecate everything else. So people would have the opportunity to get deprecation messages, adapt their code, and everybody would be happy. And yeah, we would root the deprecated entities, and of course we would end up with a slightly simpler or slightly nicer language. So our first approach, what does more specific actually mean? And we could say, well, instead of saying import java.lang.star, we could just enumerate every single item in this namespace and import it individually, and this should be compatible, right? Well, let's have a look. Can we change? This is all right. This is on. So we have a random file. And by default, we have something like java.lang _ imported by default. And the interesting thing is we don't get any error messages if we import it again. We also don't get any error messages if we import something specific again. And we even don't experience any error messages if we do things like this, right? All right, come on. Okay, it's not a, I think it's in pre-def, right? So the compiler is pretty smart. It can figure out whether we have like multiple imports of the same thing, even if we are reaching through aliases. For instance, this class we are importing here is actually a type alias to the java.lang.class, but the Scala compiler can figure this out. All right, so we see here that's just an alias. So what's the issue with replacing the star import with a specific import? Well, now my cursor has disappeared. All right, there it is. So imagine we have some random library which defines a class like thread, which is coincidentally it's like the same name from java.lang from the java.lang namespace, and we import it and use it, and everything is fine. But if we replace our star import with a more specific import of java.lang thread, yeah, right. Now we have to wait a bit. Yeah, all hell breaks loose because suddenly the reference to a thread is not ambitious anymore, and the compiler can't really figure out what it should do in the situation. So we can't just replace a star import with an enumeration of all of imports of all the types in there, because these imports have the star imports and the specific imports have different priorities in the compiler. And to actually deal with this, we would need to change the language or the specification or the compiler even further, and for instance introduce something like an annotation which tells the compiler to treat this specific import with a lower priority or something like that. So that something like this could be a workaround. So let's just assume that we have solved our first issue in the game plan. So replace our star import with more specific imports actually worked out somehow. So now the next thing we would want to do is to identify and deprecate non-desirable entities. And well, there is yet another problem. How can we deprecate imports? So something like this just doesn't work. It's like not supported in the language. This would be yet another language change to accommodate our simple change to the language. Okay, so let's completely abandon our first approach and let's just think about another approach. Maybe instead of replacing our star import with more specific imports, we just create aliases in the Scala namespace. We have already seen this. So for instance, the file predev, scala.predev is a good example of this because it does a lot of this aliasing already. So for instance, string is aliased, class is aliased. We could just add another 20 or 30 entries, add deprecation annotations. It would work perfectly fine, right? So well, now we're hitting a completely different and even more complicated issue. The problem is we can do type aliases, but we can't do term or value aliases. So let's just go to this class. What this means is that we can create a type alias with type string equals java.lang.string, but we can't do this thing. The compiler complains that java.lang.string is not a value, which is kind of correct, because in Scala we have companion objects, and these companion objects are values, and we can treat them as values, but Java classes don't have such a thing. And the problem with this is that if we aliased the type but not the value, we and then removed the java.lang import, we could do things like new string, but we wouldn't be able to do things like value a string.value of n anymore. So basically we would lose access to every static member of classes inside of java.lang. So this isn't that workable either. All right, so yeah, absolutely. So what we could do, I'm just. So where is the? Okay, looks like I didn't write it down. So basically, what we could do, we could create forwarders automatically. So if somebody writes down something like val string java.lang.string, what we could do is something like we could synthesize something like string. Now just ignore the way how it's implemented. We could do something like this. We could say, well, create some instance, and let's define all the classes, all the members, all the static members of string, and let's just forward it. So basically this line, that the compiler turns this line into this line. And if we try it, it works. But now the big issue is, like, in every place where we use string.value of, we would need to create such a forwarder. And when we create such a forwarder, and now it is a value, the question is, how does it relate to java.lang.string? And it doesn't actually relate to it at all. And how do these forwarders in different files relate to each other? How does equality work? How does reference identity work? And we are just opening a new world of pain with problems we haven't thought about yet, and which are like things we are not too eager to touch, because like the benefits are not that large, but the disadvantages can potentially be devastating. So let's so our second approach also didn't work out that well, and now it's like, wait a minute, we are now talking about adding hacks to adjust the priority of imports, or synthesizing objects with forwarder methods. How did we actually end up here? We just wanted to remove this simple single import.java.lang.star line, and that's basically the reason why things haven't changed until now, because it's like we have multiple approaches, and every approach has unexpected consequences in some sense. All right, so another topic, it's now the second topic I want to speak about, is we have this thing called implicit numeric widening conversions. Java has them, Scala has them, and a lot of other languages have them too. What it means is that numbers of smaller number types are converted to larger number types on demand. So, for instance, byte can be converted to short, int can be converted to long, float can be converted to double, int can be converted to float. What? And long can also be converted to float. And it's like, what? It's like we have like a method scramble. It takes a float. We call it with an instance of a long, and it like compiles, and now there is some result value which doesn't make that much sense. And wouldn't it be reasonable if code like this was a compiler error instead of converting our perfectly fine but wrong floats in this or longs in this place to floats? So if we want to do this, there are a lot of other questions. Like, we can't just remove it in one place and keep it in another place. So for instance, we have like this list of numbers. There's like a 10 in it, a 5 in it, and a 2.5 in it. And currently what it does is that the compiler looks at the elements and decides that the best type for this list is list of doubles. So it basically converts 10 and 5 to double because there's a 2.5 in there. And if we decide that we don't want to do these conversions anymore, we need to find another super type for this list, because even without an implicit conversion, we can put different things in a list, and the list just computes a working super type for them. So yeah, if we don't convert our integers to doubles, we get a list of any wall, and any wall is probably the most useless type you can think of. It's like there's just nothing you can do with it, but at least it will tell us that something bad happened. In a world where we had union types, we could imagine another solution, which is the list would just enumerate the different element types. So if we put integers and doubles into a list, we would get a list of int and doubles, which is also not useful, but at least the compiler tells us exactly at this point what went wrong. And if you look at a list of int and double, you see, well, either I convert my integers to doubles or my doubles to ints, and problem solved. So now the problems. ScalaSphere handles conversions in multiple places. So I did this change like 2 or 3 years ago, and there are implicit conversions in every primitive type. So scala.long has some conversions long to float and long to double. Short has some conversions also float to double. So we could remove them, but we shouldn't, because this file is auto-generated. So we would have to change the table with the auto-generated implicit conversions, regenerate our files for the primitives, and then we would realize that actually nothing has changed, because the compiler doesn't really use these methods. They are just there for show, or just to make it more explicit to the user what could happen, but the compiler does his own thing. So what we actually have to look at is like this nice table with numbers, and called name to weight. And the amazing thing which happens there is that the compiler has 2 types. One is the type of the actual number, and one is the type of the number which we would need. So for instance, int and float. And to decide whether it can convert, it just divides one by the other and has a look whether the remainder is 0. And this is like, I'm not sure if it's like cool or crazy or something, but that's the way it works. And I shouldn't do that here. It's like it was probably more crazy before, so I shouldn't complain. So actually changing it is quite nice. Just pick a new number which hasn't been used before and is not divisible by anything we don't want it to be. So we basically yes. So basically we have like our integer numbers in one hierarchy, with like char as a special case, and our floating point numbers in the other category. So what this means is that like an int can convert to a long now, and a float can convert to double, but they don't mix anymore. An int does not convert to float or a double anymore. And that's actually a bit saner and is more the way that we want things to work. But actually that's not all of it. So the problem with list, with computing a decent supertype for list in the earlier example is handled in yet another place, which is related to constant folding. So we actually also need to change constant folding to tell the compiler in which range we basically we want to convert things into each other. And after that it kind of works, but at the last time I tried to get it included, it was too controversial. The thing is that you can't just change it and tell people, well, bad luck if you have like thousands of lines of codes using this thing. So migration requires the compiler to support both behaviors. So every place I showed you doesn't need to be changed the way I showed you, but needs to be duplicated and carry one version for the old behavior and one version for the new behavior. And ideally, we would have a language feature import, like import language.no lossy widenings, which does this for us. But the problem is that with these language imports, they can be scoped. It's not like it's a compiler flag which is either on or off. Language imports can be constrained to some lexical scope and no other. So it's not an on-off switch for the compiler globally, but every time we would apply such a widening conversion, we would have to check, is this language feature implicitly available? And only if the language feature is implicitly available, we would be allowed to apply these conversions. So yeah, we would probably have to do that inside the implicit resolution algorithm, because it's not like really tell the compiler do these conversions, but here are some conversions, and the compiler has no idea whether these are the conversions we want to avoid or not, or if there's just some completely unrelated conversion which the compiler can just apply. And yeah, that's probably the implicit resolution algorithm is like not the part of the compiler where you want to add hacks. So now we have like 15 minutes left. I think yeah, I think it works. Ether is kind of a small one. So the third topic is right biasing either. So what does this even mean? We have this class ScalaUtil either, and it can either be left or right. And left is the bad case, and right is the good case. And this is only a convention unlike Scala.option or ScalaUtil try. And people complain about the unbiased behavior of either, which means the good case is not favored over the bad case. For instance, this means okay, let me just get some random either. So every time we want to transform some value of type either, we can't do, for instance, map and say, well, I have like a number, I want to double the number. It doesn't work, there is no value map. We have to tell either every time we want to do some transformation, well, I only care about right. Right is my success case. I don't care about left. And only if I do like right, at every step, and for instance, let's say right dot map. Now we want to triple it. During each or between each operation, we need to tell it explicitly that we want to have this right projection again. And for comprehensions, this gets even more painful. And So let's just make it right biased. And sure, what it would change is that now instead of having to type right and then map or flat map or stuff, we could just do this and everything would work fine. And this is not trivial, but there wouldn't actually be many difficulties with it. The one thing which is kind of painful but required if you want to support four comprehensions is the filter method. So if you have like some option and filter on it, oh no, and the predicate doesn't fail, the predicate fails. Oh god, what does it do? Oh, right, thanks. So option just returns a none, because none that has neither a value nor a type, it just can return a none and everybody's happy. The same with try. Try has a success of some value or a failure of some exception. And if we do exactly the same with some imports, we see that try has just chosen some random exception for us and some random message for that exception, and everything is fine. But if we have like either and want to filter on it, we run into issues, because if our filter fails, we actually need to provide some value for our failure. So if we have like, let's just get a right here. No, you're right, please. Right, yes, you have a right. So if we filter this in some way, we actually need to provide the left value instead. And the current API is kind of fun. They have like avoided this issue by the following return type, option of either, which basically means if it's a sum, it's only ever gonna be a right, a sum of right, and if it's a left, well, we don't return an option of left, we would just return none. So we don't have to provide any value for our left. And if we actually wanted to provide a filter method, we would have some predicate and the type of the right side of our either to Boolean for the predicate function, and we would have something like this, well, 0 of the type of the left side of the either. And the problem is this doesn't work in four comprehensions because we can't provide the second argument list. So we would either have to do something like implicit 0 of L, and this is pretty ugly because we would litter our code. We would need to litter our code with like implicit while I equals 0 or stuff like this. Or making it a bit nicer, we would require a monoid of our. We would require that our left, that the type of our either left element is a monoid, but we don't have a monoid type in the standard library, so we can't do that either. So we are kind of in a bad situation that we can improve either somewhat, but the last bit of improvement we actually want to have is blocked on some standard library extension or inventing a better way to do this. So, all right. So what I wanted to show you is that sometimes changes to the language might be desirable. I'm not saying that the changes I showed you are the best thing ever, but even for things which look simple, there are a lot of compatibility concerns. There are a lot of unexpected consequences which you just can't know without actually doing the work and seeing where things fall apart. And implementation complexity is also a big issue which you have to deal with. And this means that even small changes sometimes require disproportional efforts, and in practice this means many people just spend their time on different topics where the cost-benefit ratio is much better. So thank you very much. Do you have any questions?
Any questions?
Yeah.
Maybe more a comment than a question. I think it's either a non-biased, either is just a fact, and one can either use a Scala Z disjunction or just import an implicit or create an implicit that would just right bias it. So I don't think never has been an issue for me.
Yeah, there are certainly other options, but the problem is that either is in there in the standard library, and I think the current state of it doesn't help anyone. So it's like either we deprecate it or fix it or do something with it to make it more useful. And yeah, so there are certainly other options out there, but yeah, we still have the responsibility to actually ship a standard library which doesn't contain stuff where people just grab some third-party library instead.
Good one. Scala Z actually got this validation model, which is right bias either, and it uses implicit monoid to create a left. Yeah. And you told us that there is no monoid in Scala standard library, so why don't you add monoid and formalize monads and so on in Scala standard library? Wouldn't we benefit from that as Scala programmers?
Yeah, I totally agree. The thing is like that the things we actually want to have really depend on a lot of other changes which are quite obscure. So basically the improvement to either with the monoid for left requires some type classes or monoid applicative functor. It's like if you add monoid, you should probably add all the other stuff at the same time. And to do this properly, we would need to fix the implicit resolution of type class instances in contravariant cases. So it's basically the ordering problem where ordering is contravariant. Only if you have like an ordering for like your specific car over there, an ordering of car, and there is some ordering for like any out there, the compiler will always pick the any, which is absolutely not what you want. And this change probably needs to be implemented first before we can standardize on the type class hierarchy. And only after we have the type class hierarchy, we can think of actually using it for useful stuff like either.
All right. So you've done a really good job explaining why stuff is complicated in unexpected ways. So what do we do with Scala? Do we just give up?
It's like, no, I think we just need more people trying different approaches and different designs. I think there might be approaches out there which I have never thought of, and somebody comes up with them and it can be discussed, and maybe there's a better way forward. For instance, it's like the compiler already has some compiler flags to adapt the imports, and I always have to smile a bit or laugh out loud a bit if people say, well, I use no predef import to not having, so that I don't have to deal with all the horrible stuff in scala.predef. And I'm thinking, well, did you have a look at the other imports in there? It's like scala.predef is the least of your problems.
Okay, thanks Simon. That's us for now, and we'll be back in 10 minutes after coffee.